Since thousands of years ago, humankind has wondered if we're alone in the universe. Democritus and Epicurus were the first to speculate about aliens in 400 to 300 BC. They considered the universe as a jostling of atoms and regarded it highly likely that there were other inhabited worlds out there. To them, the idea of our world being the only one is as unlikely as if a single ear of wheat grew on a vast plain. Of course, their ideas of atoms and other Earths were different than the concepts of atoms and planets in modern science. Their concepts were more similar to the idea of multiple universes in modern physics. This idea wasn't popular at the time and was left unexplored. Since then, humanity has made great strides in exploring our solar system and beyond. The idea that this universe is too vast for us humans to be alone has taken a deeper root in our collective minds. But despite all the scientific advancements in space exploration, humanity has yet to find any evidence of intelligent life. But that doesn't mean there isn't any out there. In recent years, astronomers have detected mysterious signals coming from space that could be proof of extraterrestrial civilizations. One of the most intriguing signals is the fast radio burst, or FRB for short. FRBs are brief but extremely powerful pulses of radio waves. They last for just a fraction of milliseconds to a few milliseconds, but pack as much energy as the sun emits in 3 days. Scientists believe that FRBs are generated by powerful astrophysical events such as supernovae or merging neutron stars. But there's another possibility that scientists can't ignore, that FRBs could be messages from extraterrestrial civilizations. There have been several theories about how an advanced civilization could use FRBs to send messages across the universe. One theory suggests that a civilization might use an artificial structure known as a Dyson sphere to harness the energy of their star and power a massive transmitter. This transmitter could then be used to send powerful beams of radio waves across the universe. Another theory suggests that FRBs could be generated by alien spacecraft as they travel through space. The first FRB was discovered in 2007 by Duncan Lorimer and his student David Narkovic. That's why FRB is also commonly referred to as the Lorimer burst. Narkovic was looking through archived pulsar survey data when he found an anomaly. The anomaly was found in archived data recorded by Parkes Observatory on July 24, 2001. What they found was a spike of dispersed burst, less than 5 milliseconds in duration. It was located 3 degrees from the small Magellanic Cloud, a dwarf galaxy in the Milky Way. Lorimer and Narkovic published their findings in a paper titled "A Bright Millisecond Radio Burst of Extragalactic Origin." In the paper, they ruled out several possible explanations for the burst, such as interference from terrestrial transmitters or local objects such as comets. They also ruled out any known astronomical phenomena that could explain the burst. That left one intriguing possibility, that the burst was of extraterrestrial origin. Since then, astronomers have detected more FRBs. As of 2022, there are more than 100 recorded FRBs. Most FRBs were one-time events, but there are some interesting FRBs that seem to be repeating. That is, they're coming from the same location in space. One of the most famous repeating FRBs is FRB 121102. This FRB was first detected in 2012 by the Arecibo Observatory in Puerto Rico. In November 2015, astronomer Paul Scholes at McGill University in Canada found 10 repeated fast radio pulses in archival data gathered in May and June 2015 by the Arecibo Radio Telescope. These bursts have properties that were consistent with the original FRB 121102 detected in 2012. Just like the 2012 signal, the scientists ruled out the possibility of it originating from inside the Milky Way galaxy. Because of its repeating nature, scientists ruled out self-destructive cataclysmic events that could occur only once, such as the collision between 2 neutron stars. In fact, the data supports 4 origin hypotheses. The first possibility is from a pulsar, a younger rotating neutron star. The second possibility is from a magnetar, a highly magnetized neutron star. The third is from highly magnetized pulsars traveling through asteroid belts. And the last hypothesis is from an intermittent Roche lobe overflow in a neutron star, white dwarf binary. On December 2016, 6 new FRBs were reported in the same direction. As of January 2019, this is the only 2 instances in which these signals have been detected twice at the same location in space. Scientists calculated that FRB 121102 is located at least 1,150 astronomical units from the Earth. This excludes the possibility of it being from a human-made source and is almost certainly extragalactic in nature. As of April 2018, FRB 121102 is thought to be co-located in a dwarf galaxy about 3 billion light-years from Earth, with a low luminosity active galactic nucleus, or a previously unknown type of extragalactic source, or a young neutron star energizing a supernova remnant. These kinds of repeating FRBs are useful for scientists. They allowed researchers to look for patterns in a seemingly random phenomenon. These patterns can reveal a lot of information and allow for more calculations to be made. Another interesting repeating FRB is FRB 180916.J0158+65, or later known as FRB 201-80916b. It was also less formally known as FRB 180916. It was discovered in 2018 by astronomers at the Canadian Hydrogen Intensity Mapping Experiment (CHIME) telescope. According to a study published in the 9th of January 2020 issue of the journal Nature, CHIME astronomers, in cooperation with the radio telescopes at the European VLBI network and the optical telescope Gemini north of Mauna Kea, Hawaii, were able to pinpoint the source of FRB 180916 to a galaxy approximately 450 million light-years from the solar system. This is a Milky Way-like galaxy named SDSS J015800.28+654253.0. Before the observation of this FRB, only 2 types of FRBs had been observed: non-repeaters and repeaters. As its name suggests, non-repeaters are single-instance FRBs. This type of FRB is possibly associated with catastrophic stellar events. Meanwhile, repeater FRBs are not one-off, but manifest recurring, unpredictable, sporadic, and irregular radiation bursts. Researchers haven't been able to pinpoint the sources of these repeater FRBs. FRB 180916 seems to represent a third and new type of FRB. Researchers have categorized it into a third type, periodic repeater. The radiation activity of a periodic repeater would repeat over a fixed period of time. In the case of FRB 180916, its radiation activity repeats over a period of 16.35 days. It emits a burst of radiation for approximately 4 days, followed by an inactive period of about 12 days. Then the cycle repeats. The 4-day radiation is not homogeneous. It's categorized by a pattern of subbursts. The radiation activity within the 4-day bursts never follow exactly the same pattern. However, there is enough similarity to suggest that they form part of an original repeating pattern with an internal structure of some complexity. This original repeating pattern would then undergo distortion in its 450 million year journey to Earth. On 7th of June 2020, astronomers from Jodrell Bank Observatory reported possible evidence that FRB 121102 exhibits similar behavior as FRB 180916. FRB 121102 would produce radio bursts in a window lasting approximately 90 days, followed by a silent period of 67 days, so it repeats every 157 days. This behavior is nearly 10 times longer than the 16-day period exhibited by FRB 180916. scientists hypothesized that this FRB 121102 may be associated with the orbital motion of a massive star, a neutron star, or a black hole. On April 28, 2020, another FRB was detected from the same area of the sky as a known magnetar, the magnetar SRG 1935+2154, located inside the Milky Way galaxy. This FRB, known as FRB 200428, is the first FRB detected from inside the Milky Way. It was thousands of times less intrinsically bright than previously observed FRBs. However, its close proximity to Earth made it the most powerful radio burst observed until now. This discovery established magnetars as at least one ultimate source of FRBs. What causes the magnetars to produce these FRBs is still unknown. This theory of magnetars as the source of FRBs was further supported by a recent discovery. In 2021, astronomers detected an FRB source producing nearly 1,900 bursts for 82 hours spread over 54 days. This hyperactive behavior of FRB 20201124A has allowed scientists to categorize the host galaxy and the source. So far, most evidence points to a magnetar as the source of this FRB, but there was something strange. The observed data suggested that the strength of the magnetic field and density of particles around the magnetar were fluctuating. It suggests a complex, dynamically evolving environment around the magnetar. Such an environment is unusual for an isolated magnetar. That's why the researchers hypothesized that there's something else in the vicinity of the FRB engine, possibly a binary companion, and that companion could be a hot blue B-type star, which is often found in companions with neutron stars. But there's still something strange. These magnetars are thought to be found in regions where star formation is still occurring. But FRB 20201124A was found in a galaxy a lot like the Milky Way. There's not a lot of star formation going on here at the Milky Way, so a similar situation should be occurring there too. And FRB 20201124A isn't the only FRB source found in a galaxy devoid of star formation. This suggests that there are still more mysteries to be solved about these messages from space. Is magnetar the only source of these FRBs, or could there be other sources? What do you think? Could it possibly be intelligent extraterrestrial lives? Let us know in the comments section below.